This is Digital Sampling by Jada Davis. The motivation for this lab was to utilize the capabilities of the Digital Data Acquisition, or DAC, systems to explore the overall accuracy of the DAC system in sampling. In the first part of this experiment, I explored the relative response of the microphone speaker system versus the direct connection provided by the audio jack. For my individual experiment, my purpose was to determine how the distance of the microphone from the sound source affected the power spectrum and how that was shown in the data collected. Both parts of this experiment were calculated in an isolated room to limit excessive noise that could affect the accuracy of the data. To gather the data to collect the relative response, the power spectrum was sampled from 10 different frequencies, being 200, 300, 400, 500, 600, 700, 1000, 2500, 5000, and finally 7500 Hz, using the 3.5 millimeter audio jack. The same 10 frequencies were then sampled using the microphone speaker system at a constant distance of 7 centimeters and constant volume of 50%. To gather data to determine the relationship between distance and the recording system, the power spectrum was sampled for a frequency of 700 Hz at varying distances, being 1, 5, 10, 15, and 20 centimeters from the speaker, and once again at a constant volume of 50%. In graph 1 on the left, it shows the sampled power spectrum values measured in VRMS squared as a function of frequency. Data for the microphone is represented by the green diamonds, and the audio jack data is represented by the blue squares. In graph 2 on the right, it shows the relative response as a function of frequency, which was calculated by dividing the power spectrum of the microphone by the power spectrum of the audio jack and then converted into a percent value. On the following slides, figures 1 through 5 show different waveforms and power spectrums in the second part of this experiment. So figure 1 shows at 1 centimeter away, figure 2 shows 5 centimeters away, figure 3 shows 10 centimeters away, figure 4 shows 15 centimeters away, and finally figure 5 shows 20 centimeters away. It can also be observed in the waveforms that the further away it got from the speaker, the more noise that was collected as well. In graph 3 on the right, it shows the sampled power spectrums as a function of distance. To conclude, as seen in graph 2, the relative response of the microphone speaker system versus a direct connection was rather inaccurate. We saw that it averaged about 20 to 40% accuracy, with a few outliers as the frequencies got higher, which proved to be rather inaccurate when comparing the two. As seen in graph 3, the distance of the microphone from the speaker and the recorded power spectrum have an inversely proportional relationship. As the distance of the microphone was positioned away from the speaker increased, the power spectrum inversely decreased as well.